Hi class, welcome back. We are on section 1.10. Today we're going to be talking about lines. So the last section we talked about the rectangular coordinate system. So now we're going to be talking about the graphs of different objects, right? So the first object that we generally talk about the graphs for, besides a point, is a line. So I know we already talked about circles. So now we're going to get into the first functions / equations, which are the equations of lines. So first let's talk about the slope of a line. So the slope of a line is the rate at which the line either increases or decreases. Okay, it's the ratio of the change in the vertical movement with the change in the horizontal movement. Okay, so we have a grid. This is my line. I have some point on a grid. The slope is how much we move up or down as we move left or right. So generally we talk about moving in the positive direction, right? We're going from negative to positive. So we talk about how do we move up or down as we move forward in the positive direction. Okay, so start with a point x naught, y naught. I want to end up somewhere else. Okay, so we talk about moving left and right and up or down. Okay, so again, generally we only talk about moving to the right, and then how much we have to move up or how much we have to move down as we are moving in the forward direction. Okay, so the distance between this point and this point, as we've seen from the last video, is x1 minus x naught. The distance here is y1 minus y naught. And remember, the slope is the rate, right? So it's a ratio. Okay, the ratio is the vertical change compared to the horizontal change. So this is my vertical change, this is my horizontal change. So my m, which we call the slope, okay, so this is the value, the variable that we use to represent slope, it's actually a constant, is my rise over run, as we've learned from way back in like 6th grade, okay, which is our up and down versus our left and right, or my change in y over my change in x, or what we call delta y over delta x. So this is a calculus type definition. You will see this symbolism in calculus everywhere. My change in y, delta y, is y1 minus y0, and delta x, my change in x, is x1 minus x0. Okay, so if our graph of our line generally looks like this, then my slope is negative because my slope is decreasing, right? So again, we talk about how we move from left to right. If I had a little guy sitting on this hill, he would slide down, right? So that's a negative slope. If I had a little guy here, he would be walking upwards. He would be going uphill as he moved from left to right. That's a positive slope. My slope is larger than 0. Okay. Here, if I were to walk, it would be easy peasy, lemon squeezy. There would be no slope. Okay, I'm not going uphill or downhill. I'm just flat. Okay. Here, this is undefined because I can't say that this is increasing, right? I can't say that it's decreasing. I can't say it's negative or positive because I don't know. Is this going up or is it going down? It's kind of doing both. And it's definitely not flat. So something like this we call undefined. Okay. So there is 0 change in the left and right movement as I move up or down. Okay, and again, we're not allowed to divide things by 0, so algebraically it makes sense that it is called undefined. Okay. A line only has 2 parts of interest to us, one of them being the slope, which we just talked about, its rate of change. The other is the y-intercept, okay, where this graph intercepts the y-axis. Okay, here there is no y-intercept in this case. In that example, I should say. Okay, so a line intercepts the y-axis at a point 0b. We call b the y-intercept. Okay, so m is our slope. 0b is the point where it intercepts the y-axis. So in application problems or word problems, we call this our starting point. So in application, we also call it our initial value. Okay. The slope-intercept form of a line is y equals mx plus b. Okay, this is the form of a line that I prefer to see all of our equations in. right? So whenever I ask you about anything about the equation of a line, this is the form that I want, right? So when graphing a line in this form, it's actually very easy. We start at our initial point, our initial value, and then we apply our slope, okay? So we apply our slope first in the forward direction. Sometimes, however, our slope is very large. Applying it in the forward direction, we can only find one or two values. So then it'll be important to apply it in the backwards direction. Just remember, in the backwards direction, you're moving negative, right? So if I was going over and up in the forward direction, I'm doing the exact opposite in the backwards direction. So I'd be going backwards and down instead, okay? So if our equation is in standard form, which is ax plus by equals c, then to graph this, we graph this slightly different. We find the y and the x intercepts, and we connect those 2 points with the line. So this way is a little bit easy. Basically what you do to find those intercepts, remember y is 0, so this just goes away, and it's easy to solve for my x. For the x-intercept, for the y-intercept, x is 0, and then it's easy to find the value that we have. So standard form is easy to graph by just finding 2 points. You could also put your standard form and transform it, I'm not going to say transform it, manipulate it into the slope-intercept form and then graph it that way. That's another option as well, okay? So again, here, so another way that we can do this is to put into slope-intercept form and graph it with the initial value and the slope. So let's go ahead and do an example. Okay. First, we're going to graph y equals 2x plus 3, and then we are going to graph 2x plus 4y equals 8. So for the first one, we start with the initial value, apply our slope. For the second one, we will find the x and y intercepts and connect those 2 points with a line. Okay. So our initial value is 3, so that's where our first point will be at. Okay. From there, we apply a slope of 2. Okay. So remember, it's rise over run, or the change in y over the change in x. So we need a fraction. 2 as a fraction is 2 over 1. So that means as I move in the forward direction, I will go up 2 over 1, or you can think about it as going over 1 up 2. It doesn't matter. I'll always end up at the same point. So notice that since my y-intercept, my initial value is sort of high up here in the grand scheme of the graph, we're really only going to be able to plot 1 point. Okay, so I'm going to go over 1, up 2, and make a line or a new dot. Okay, if this is pen and paper, I would just make a new dot and then connect the lines. Okay, and I kind of run out of room. So what I'll do is I'll start to go backwards. So I'll go backwards 1, so that's a negative direction, right? The opposite of what I was going before. So when I go up or down, I have to do the opposite of that as well. I was going up before, but now that I've gone in the negative, I got to go in the negative again in order to keep this positive, right? So I go down 2, okay? I can continue my line, over 1, down 2, continue my line, over 1, down 2, continue my line, over 1, down 2, so forth. And then when I'm done, I just put arrows at the end of it and I can label my graph, okay? Now generally when I do this on a piece of paper, I just put a dot on all of these places, right? And then I would take a ruler and then connect all of those dots with a line because I don't have a computer program to do that. So obviously when I do this one at a time, it can be perfect, right? But when I'm doing it by hand, it's not so perfect. So I draw my dots and then I connect them with the line. Okay, so that's my graph for A. For B, 2x plus 4y equals 8, what I'm going to want to do is find the x and y intercepts and then graph it that way. Okay, so my y-intercept is when x equals 0. Okay, so if x is 0, this goes away, and I'm left with 4y equals 8. Okay, solving for y is very easy. Divide both sides by 4, right? I'm undoing PEMDAS in the opposite order to isolate my variable. So I have y equals 2. So that means 0, 2 is my y-intercept. Okay, when y is 0, I get 2x plus 8. Okay, again, y is 0, 2x equals 8. Okay, solve for x, and I get x is 4, that gives me a point of 4, 0. So when I take my graph, I plot my 2 points, okay, 0, 2, 4, 0. I just take a ruler and connect those with the line, and I have my points, okay. Now if I was going to take my equation and solve for y, put it into slope-intercept form, I would get the equation y equals, I know you can't see this too well, negative 1/2 x plus 2, and that agrees with what I have, right? So if I start at 2, okay, and then I apply this minus 1 over 2, down 1 over 2, I land on my line. Down 1 over 2, I land on the line. Down 1 over 2, and so forth. Right here, I would go up 1 and backwards 2. Up 1, backwards 2, because it's negative, right? So instead of going down as I move backwards, I would go up as I go backwards because it's negative, right? And my equation agrees with my line. I have a negative slope. Here, the m value is negative, okay? So now let's talk about graphing in general, okay, for equations of lines. So if I'm given certain things, there is specific equations that are easier to use than others, and we'll talk about how to graph using what I'm given, okay? So let's say I'm given any point and a slope, any point, okay? So I have my slope, and I have any point, which I'll call x naught, y naught in this case, okay? So the equation, the easiest thing to use is the point slope, okay, which is y minus y naught equals m times x minus x naught. This is the easiest form to use if I have any point and a slope. So what I'm going to do is, when I'm graphing, okay, I would plot my point, and then from that point, I would just apply the slope in both directions. Very similar to what I did before here, except my point that I'm given doesn't necessarily have to be the y-intercept. It could be the point that's here. So I would start with this point that's given to me, and then apply my slope in both directions, just like I did here. Okay. So let's say I'm given the y-intercept and a slope. So here I'm given m and my b. Well, the option should be very easy. I'm going to use the point-intercept slope, the slope-intercept form, the y equals mx plus b. Okay. So let's notice too what's happening here. My name here, the point slope for the equation of a line in this case, is based on what I'm given. I'm given a point and I'm given the slope. The slope intercept is when I'm given the slope and I'm given my y-intercept, right? So this, I'm going to plot my y-intercept just like here. I plotted a general point. Here I'm just going to point my y-intercept, and then I apply the slope in both directions. Okay. The only one we didn't talk about is this first one because I don't like it. I think it's terrible. I will not show you guys how to use this because I'm sorry, I think it's useless, to be honest. It's math, it's algebraic. It goes along with what we're talking about, but it's never used. Nobody ever uses this. No one ever puts their equation in this form. Okay. We always use either the slope-intercept or the standard form, which is what's happening when I'm given 2 points. If I'm given 2 points, then I'm still going to use the slope-intercept, okay, which is y equals mx plus b. The only difference is I'm going to take my 2 points, I'm going to plot them, I'm going to figure out what my slope is, and I'll just continue that slope, right? So if I already have 2 points, I can connect the points with the line. Algebraically, I would find out what that slope is and put it into y equals mx plus b. Okay. So we're going to use the slope to continue the line in both directions. So if I have 2 points, I can draw a line. If I need to be even more accurate than that, I can continue the pattern of the slope between these 2 points to continue plotting new points on my line. Okay. So that's for graphing. Okay. If I need a graph and I'm given these things, these are the equations that I'm using. Okay. But more importantly, if this is what I'm given, then this is how I'm gonna graph. There's a relationship between graphing and modeling. Okay, graphing and the algebra, right? Making the equation that I need to use. If I have enough information to graph something, right? If I have 2 points and I can make a graph from my 2 points, well then all I need is 2 points to be able to graph to create an equation. If all I have is the y-intercept and the slope, I have enough information to make the equation, given that information. If all I have is some generic point and my slope, that's enough information to create my equation. So whatever I have, if I have enough information to graph, then I have enough information to create the equation for that graph. And that's true for anything. If I have enough information to make a quadratic, right, to graph a parabola, then I have enough information to find the equation for that parabola. And that's true for, again, any equation that we have. Okay. So again, let's say that we're given a y-intercept and a slope. Okay, so 0b and m. So how do we find the equation for this? What we do is we plug the values directly into the equation, right? I know m already. I know b already. That's it. I don't need anything else. Okay. Let's say that I'm given any point and a slope. So this x naught y naught equals m. I'm going to do pretty much the same thing. I'm going to plug in the point and the slope. So that means I'm going to plug in x naught for x and y naught for y. And this value that I have for m, that means the only thing I don't know is b. But the only things that I need for this equation are m and b. Y and x are variables, m and b are constants, right? So m and b will have values. Y and x need to stay as y and x. So I'm going to take these specific values and this given value of m, and I'll solve for b. And once I have b, then I have everything, right? So I'm going to plug in y naught, I'm going to plug in x naught, I'm going to plug in m, I'm going to solve for b, okay? So to solve for b, I just subtract m times x naught. So my b is y naught minus m times x naught. So if I put those together, I already know m, now I know b, right? I solve for b and put m and b together in my equation. So this will look like y equals m times x plus my value of b, right? My value of b is given by these points, the y naught minus m times x naught. Okay, let's say I have 2 points, okay, x naught, y naught, x1 and 1. Then I will find the slope, okay, using the equation for slope. So change in y over change in x. Now what happens is that I have the slope and I have 2 points, but all I need is 1 point. So if I have the slope and 1 point, I can do what I did in this previous case here and solve for b, right? So now I know what m is, right? And I pick either one of these points. It doesn't matter which one. And I do the exact same thing I did here. I plug in m, I plug in this point, and I solve for b, right? So using the method outlined above here with either of your points and the slope that I just found. Okay. So let's go ahead and do that. So y equals mx plus b. I know that b has this form, y naught minus m times x naught. And I know that m has the form of y1 minus y naught, x1 minus x naught. So I replace m everywhere I see m, right? So this is my m, x, plus this is b. But in this b, I've replaced m with the m that I actually have, okay? So when I start to do my algebra, right, this plus y naught can come out to the end. So I have this times x minus my m times x naught, okay? So I can pull out that common factor of m, and I have x minus x naught plus y naught, okay? So what I did here is I subtract y naught to the other side. So now this is y minus y naught equals my m times x minus x naught. And I can resubstitute my m in. And now we have that point slope form of a line, right? The y minus y naught equals m times x minus x naught. The exact same form that I told you guys we're never going to use, right? So really we just kind of went full circle. And we verified why this equation is actually an equation of the line, right? So we would take this point slope form as a tool to help us to get to what we want, which is y equals mx plus b, right? So we can always use this, right? But we don't want this as the final form of our equation of a line. That's not what we want. We can use this, however, again, as a tool to get to my y equals mx plus b form. Okay. So now let's talk about parallel lines. Okay. So parallel lines never touch, they never intersect, and they do not overlap. Okay. So in order for two lines to go forever in the positive and negative direction and never touch each other, that means they have to increase or decrease at the same rate. So in order to increase or decrease at the same rate, that means you have to have the same slope, okay? Because the slope is your rate of increase. So two lines, which we'll call L1 and L2, are parallel. So the symbol for parallel is two parallel lines between the names of your lines, okay? If the lines never intersect each other. So again, this means they have to have the same slope. So here L1 is the subscript for M and L2 is the subscript for this M. This signifies that it is the slope of the line L1 and this is the slope of the line L2. Okay, so that means that our slopes have to be separated by a finite amount as well because they can't lie one on top of the other, which means that they intersect the y-axis at different points. Okay, so the b value for L1 cannot be the same as the b value for L2, right? Those intercept values. Okay, so again, notice same rate of change, okay, because they're parallel. They have different points that they intersect the y-intercept. Okay, so for instance, this one, I'm here. To get to the next point, you can see I can go up 1, 2, over 1, 2, 3. Okay, same thing here. I can go up 1, 2, and then over 1, 2, 3, and both times I end up right back on my line. They have the same slope. Okay. Perpendicular lines. Now, perpendicular lines are a little bit different. Perpendicular means orthogonal. Okay, so another term for perpendicular is orthogonal. Basically, what this means is that they create a 90-degree angle. Okay, a right angle. So two lines, again, L1 and L2, are perpendicular, also called orthogonal. The symbol for orthogonal is this upside down capital T, okay, which should make sense because you can see that it kind of forms two right angles, one on the right side, one on the left side. So two lines are orthogonal to each other, perpendicular, if they intersect each other at a right angle. Okay, very similar to how the y-axis and the left axis form a right angle with each other. Okay, 90 degrees. So this means the slopes are negative reciprocals of each other. Okay, they are negative reciprocals. That means you take the slope of line 1, if you flip it around, reciprocal, and then you change its sign, that will be the slope of L2. Okay, so the slope of L1 is the negative reciprocal of L1, right? So this is the way that they are related to each other, right? Or of L2, I'm sorry. So, okay, these two lines, doesn't matter which one I call line 1 and which one I call line 2, they form a right angle. Okay, so again, on a graph, we signify a right angle with this little square. So you'll see that when we talk about trig. And if you took a geometry class before this, you also use that in geometry, right? So here, from this point, I can go up 3 and over 2, and I land on my line. For the other one, okay, so again, think about it from here. I went over 2 and down 3, right? I went up 2 and in the negative direction, so that's a positive and a negative. Or you can think about this as a positive and a negative, okay, because I have a negative slope here. For this one, I went up 2 and over 3. So this is a positive slope, negative slope. So I already know that the signs are different, okay? Here I went up 3. Here I went up 2. Here I went over 2. Here I went over 3. So they are flipped, right? So instead of going up 3 over 2 like I did here, I did the opposite, up 2 and over 3. So they're negative signs and they are reciprocals of each other. So let's do an example. Let L1 be the line that passes through the points -2, 3, and 5, -7. Consider the point 4, 9. Okay, so this is a point randomly in space. we're told L1 is a line that connects these 2 points, and we have a third point randomly. Okay, we want to find the line L2 such that, okay, every time you see this S dot T dot, this means such that L1 is perpendicular to L2 and L2 contains this point. Okay. Also, we want to find a third line, L3, such that L3 is perpendicular to L1 and L3 also contains the point. So we're doing two things here. We're finding the first line. Well, first of all, let's start from the very beginning. We have to find the equation of L1. After we find the equation of L1, we're going to find the equation of L2. Okay, the restriction on L2 is that it is parallel to L1, right? And it also has to go through this point. We're then going to find a third line that is perpendicular to L1, the first line we found, and it also goes through this point. Okay, so let's go ahead and start off by finding L1. So I need to find, first of all, the slope of the line L1. So I'll use the 2 points that are given to me. Okay. So M is going to be -7 minus 3 on the top. That's the difference in the y values. Difference of the x values is going to be 5 minus a -2, right? So this is going to give me -10 on top and 7 on the bottom, right? So my slope is -10/7. Now that I have that, I need to take one of these points with the slope that I have. It doesn't matter which one, okay? Generally, when I do this, I take the point that is easiest, right? So what does it mean to be the easiest point? Either all the numbers are positive, or the numbers are small, okay? So for both of these, neither of these have all positives for -2, 3, and 5, -7. However, I'd rather do math with 2s and 3s than 5s and 7s. Okay, these numbers are smaller, they're easy to calculate, it's easy to double something or triple something or add 2 or add 3. 5 and 7, it's still just numbers, but it's easier when the numbers are small. Okay, so again, I like to use the easiest point. That means all positive, small numbers, no fractions, etc. Right? So I'm going to use the point -2, 3. Okay, so I'm going to take the general form of my line and I'm going to plug in all of my stuff. I have an M, okay, so M will be replaced with -10/7. I have an X, it's -2, and I have a 3, okay. So whatever M and B that works for this line, whenever I have it, if I plug in 2, I should get out 3. So I have all of the information except for that B value. So I plug in all the information and I find my B. So that means my Y is 3. Okay, equals M, which is -10/7. And then for X, I have -2. And then what I don't have is B, so we add the plus B. Okay, so this is the equation that I'm working on. So you see you have a fraction here. I can say it's positive 20/7, and then try to subtract this on both sides and make this 21/7 and do all that jazz, which is fine. There's nothing wrong with that. But again, there's an equal sign, there's a fraction. Let's just multiply everything times 7. It's a little bit easier to deal with. So this is 21 now. This is a positive 20. And this is now 7b. So when you clear the fractions, don't forget about this b. It's the number one thing I see students make a mistake on, is they're just focused on both sides of the equation, but they forget about the little tag along here. So this has to be multiplied times 7 as well. So now I don't have to worry about fractions. I can subtract 20 on both sides and then divide by 7. And we get b equals 1/7. Okay. I throw all this together, and I get y equals -10/7, my M, x plus b, which is 1/7. Okay, but remember, we have several y's here, so we'll call it by its actual name, which is L1. Okay, so that's my L1. So now that I have L1, I can find everything else. So important thing to note here, you guys, if you find L1 incorrectly, then L2 is going to be wrong and L3 is going to be wrong. Okay. So you got to make sure you have the correct L1. There's always a way to check things in mathematics. How can I check this? Well, 2 ways. I can plug in -2, 3 and see if it works. And then also, or plug in 5, -7, and it should also work, okay? Because both of these points lie on this line. You can always check your work in this class, right? So for L2, I need a parallel line. So that means that L2 has the same slope, and L2 is going to pass through this line. It's not going to pass through these lines, but I do know it passes through this one. So we're going to do pretty much the same thing, same slope, but instead of -2 and 3, we'll use 4 and 9 because that's a point I know is on my line. So L2 being parallel to L1 implies that the slope of L2 is the same as the slope of L1, okay, which is -10/7. So I'm going to use the point 4, 9 with this slope, okay, and I will have this equation. 9 is my y, -10/7 is my m, 4 is my x. I do not know the slope-intercept, I don't know the y-intercept value for L2. So I'm going to do the same thing I did before. Let's multiply everything times 7, okay? 63 minus 40 plus 7. I can add this to both sides, so I get 103 over 7 is b, okay? Therefore, L2 is the m that I have times x plus my y-intercept value, 103 over 7. Right? So now I have L1, now I have L2. To find L3, I know that they're perpendicular, so I know some information about the slope of L3, and I know that L3 also goes to the point 4, 9. So I'm going to use that information to find L3. L3 is perpendicular to L1, so that means that the slope of L3 is 1 over the value of the slope of L1, and then change the signs. Okay, an easier way of doing that is just change the sign and flip it around, right? So instead of 10/7, it's 7/10. It's no longer negative. I have to change the sign as well. Okay. I know that L3 also goes to this point. Okay. So I plug in my stuff. Y equals mx plus b. I'm going to solve for b. Let's clear the fractions out and multiply everything by 10. Okay. So now I can subtract 28 from 90. Okay. And that should give me 62. Okay. And then divide by 10 is 62 over 10. This has common factors in it, so I would reduce my fraction. Always simplify your fractions in this class. So that'll be 31 over 5. So now I have my m, I have my b, put it together, and I have y equals mx plus b. So L3 is 710x plus 31 over 5. Okay. Hope that was helpful to you. We did one problem, if you notice, that talked about every single subject in this section, right? So when possible, that's how I'll try to present the material to you. Very likely that this is something that I would ask you, right? I generally ask questions like this in my Algebra 2 class, right? So you can definitely see something, expect to see something along these lines in an exam if I decide to put a question on lines in your exam. Okay, so just a heads up. Thank you guys. I'll see you on the video for section 1.11.